Hi everyone, I am Shravani from CSEB bearing the roll number 21BQ1A0587. Uh, Let me tell you about non-restoring division algorithm for unsigned integers. Uh, Instead of the quotient digit set 0, 1, the set -1, 1 is used by the non-restoring division. The non-restoring division algorithm is more complex as compared to the restoring division algorithm. But when we implement this algorithm in hardware, it has an advantage. That is, it contains only one decision and addition or subtraction per quotient bit. After performing the subtraction operation, there will not be any restoring steps. Due to this, the number of operations basically cut down up to half. Because of the less operation, the execution of this algorithm will be fast. This algorithm basically performs simple operations such as addition, subtraction. In this method, we will use the sign bit of resistor A. 0 is starting value or bit of resistor A. This is algorithm. Here, first step you need to start. Here n is number of bits in dividend. A is 0. Initially A is 0 and M is divisor and O is dividend. Uh, and next step is sign bit of A. You need to identify the sign bit, either it is 0 or 1. If it is 0, you need to shift left A and O. That means A minus M. If it is 1, you need to do shift left to A and O. That means A plus M operation you need to perform. All after completing the both operations, you need to do a sign bit of A. If the sign bit again, if it is 0, you need to do O of 0 is equal 1. If it is 1, you need to do O of 0 is equal to 0. After completing this step, you need to do n minus 1. And if n is equal 0, if n is equal 0, then sign bit of A is minus 1, then you need to do A plus m. If sign bit of A is not 1, I mean not minus 1, you need to go to next step. Quotient is in register 0 and remainder is in register A. Here you may get the final answer and you may stop the procedure. Yeah, step 1. In this step, the corresponding value will be initiated to the register. That is, register A will consider value 0, register M will consider divisor, register Q will contain quotient, and N is used to specify the number of bits in dividend. As before I said the algorithm, these are the steps. Step 2. In this step, we will check the sign bit of A. And next step is, if this bit of resistor A is 1, then shift the value of AQ true left and perform A is equal A plus 1. If this bit is 0, then shift the value of AQ into left and perform A is equal to A minus M. That means in case of 0, the 2's complement of M is added into resistor A and the result is stored into A. Step 4. Now we will check the sign bit of A again. Step 5. If this bit of resistor A is 1, then Q index of 0, that means register of 0, will become 0. If this bit is 0, then Q of 0 will become, here Q of 0 indicates the least significant bit of Q. Step 6. After that, the value of n will be decrement. Here n is used as a counter. If the value of n is equal 0, then we will go to the next step. Otherwise, we have to again go to step 2. Step 8. We will perform A is equal to A plus 1 if the sign bit of register A is 1. Step 9. This is the last step, and this step register A contains the remainder and register Q contains the quotient. Here is the example. We will perform a non-restoring division algorithm with the help of an unsigned integer. I have taken dividend as 11 and divisor as 3. In M is 11101. Initially, N, M, A, Q, and action. Initially, A is 0 and Q is dividend, and M is divisor, and initial action is begin. So I have written begin. Here the sign bit is 1, so shift AQ and do A minus M for A and go to next step. Here you can identify Q of 0 is equal 0. Then do shift left to AQ. And here you can stop the procedure and go to next step. Here A is equal to A plus M. Q of 0 is equal 0. And now do again shift left AQ. And after doing AQ, you need to perform A plus M and go to next step. Q of 0 is equal 1. Here sign bit is equal 1. Then shift left AQ and do A minus M and go to next step. Q of 0 is equal 1. This is the final step. Here you no need to do again shift left. So A contains the remainder 2 and register Q contains the quotient 3. Thank you.